for today, we're going to start looking at solving exponential equations. So as an example, you might have something like this. Maybe 3 to the x power is equal to 9. Well, guys, 3 to what power is 9? Not 3, but 3 to the second power. 3 squared would be 9, right? We want to start looking for values of x to make true statements. So what we say right here is we're solving exponential equations, and we want to know how we can solve those types of equations algebraically and specifically graphically. So, guys, the idea that the word graphically pops up again means that we're going to jump into some Desmos stuff with this. But honestly, this won't be too difficult if you've got that chart down. In order for us to answer this question, we need to be able to solve exponential equations with the, what's the first thing here, guys? Same base. We're going to look at solving exponential equations with unlike bases, and then we're also going to look at using a graph to do this. Now, guys, one thing I will tell you is this. You could get away with graphing everything, but I would like that graphing tool to be some kind of a way of confirming answers rather than finding answers. So think of that as we're going through this. Guys, really the only vocab we need to know today, right here with exponential equations. And these are going to be equations in which variable expressions occur as exponents. So you may have something like this. You might have 3 to the x plus 2 power equals 9 to the x minus 6 power. Something like that. We're going to have equations that involve exponents up there, and our job is to solve for that unknown up there, that variable x, to give us a true statement. And I'm going to show you how to do that. I'm going to show you how to do that. All right. There are some things we need to recall. Good thing Curtis isn't in here. He would say, "You're Chevy person."
I don't know.
Recall for a vehicle.
Oh, I found your house this weekend, by the way.
Huh?
I found your house this weekend.
Why are you creeping around my house?
Because Chelsea told me to.
Chelsea, did you tell him to?
Yeah.
Chelsea, did you tell him there's a big sinkhole across the road from me?
We kind of sort of found that.
Yeah? It's like a lake right now.
The ditch like drops really
Yep. Okay. You didn't find anything down there, did you?
No.
Oh, good.
Why? What are you hiding down there, Barton?
Nothing. Nothing. All right, recall this right here. Guys, we've talked about exponents in the past where I might have something like this where, oh, how do I want to do this? Let's do it this way. Guys, 4 to the second, all to the third power right here, where I have something like an exponent inside and then an exponent outside here. Would you guys agree that this is really the same as 4 to the second times itself? How many times? 3 times. So this is really 4 to the second times 4 to the second times 4 to the second. Okay, guys, here's what's really happening. How many 4s do you really have right here according to this exponent? And how many here? And how many here? So totally, how many 4s are really getting multiplied together in that situation? 6 of them, right? So this becomes 4 to the 6th power. So my question is this. Instead of writing something longhanded like I did, or write this as repeated multiplication, this 3 and this 2 right here, what do you do with that 3 exponent outside of parentheses to your exponent inside of parentheses to get that value of 6 out there as a solution? What do we do with the 3 and the 2 to form a 6? Multiply. So here's a rule. Here's a rule to remember. If ever you have something like x to the a in parentheses like this, all to the b power, this becomes x to the a times b power. And it becomes x to the a times b power. Are you okay with that? So in parentheses, 2 to the 3rd, and then outside of parentheses to the 7th. 2 to the 3rd to the 7th is the same as 2 to what power? 2 to the 3rd to the 7th is the same as 2 to what power? Somebody said it. 2 to the 21st, so 7 times 3 there, okay?
Wait, the times b, is that towards the top of the x or the side? Like
They're right at the top. They're both exponents, okay? And they're going to form some number. 8 times b is going to be some number. Just like the 3 times 2 right here, Taryn, turned into the 6, okay? All right, so that said, let me do this quickly, make some room. All right, now, secondly, another rule that you need to recall. That was the first one. Second one you need to recall right here. We've talked a little bit about this in the past. This is going to be the one that I think gets you. I want you to understand one thing. Understand one thing. If you ever have something like 1 over 5 to the second power, like this, it's possible that you can take this and rewrite this with a negative exponent. What ends up happening is this. If you ever see a fraction form like this, 1 over 5 squared, which is really 1 over 25, right? Okay, if you ever see that right here, kids, this is the same as taking this and moving it to the top like so. But if you change it and move this to the opposite side, instead of your exponent being a positive 2, it turns into a negative 2. All right, it turns into negative 2. So the rule for this is the following. If you ever have a function like this, 1 over, say, maybe a to the n power like this, if you ever have 1 over a to the n, a is a number, maybe n is a number, I don't know what it is. This is going to become equal to, if I move this a to the n up top to the other side, instead of having a positive n, what do you have? You have a to the negative n power. Okay? So if I have 7 to the negative 3, that's like 1 over 7 to the third. Or if you have 1 over 4 squared, that's the same as 4 to the negative 2 power. And I think that once we get involved in some of these examples, you'll really understand what it is or why it is that we need these rules. I guess my first question is, do you have those written down for sure? Make sure you have them, because I guarantee you, you're going to want to come back to those at some point. I'm going to make this note right now. If you ever get stuck on a problem, it's probably because of one of these 2 rules right here. Okay? If you ever get stuck with a problem, come back and take a look at these 2 recall rules right here, because that's probably where you're getting stuck at. All right? Okay. Let me know when you've got that down. Let me know when you've got those recall rules down. Yep. Saw a good game the other night. Crazy. That's your Christmas.
I'll take it. Is that an
Were you thinking of me at all during that game? Thinking, oh my God, Parsons gonna be.
With the minute left, I was like, thank God I'm not gonna be at school tomorrow. And then when it was over, I was like,
Then it went the other way. You know what I said at the end of the game? Thank God she's not gonna be at school tomorrow. Yeah.
1 over a, is that r?
That's an N. I'm sorry. That's an N. Thank you. Is that a little better? No, well, not really. But. Okay. Hey, here we go. Guys, right here. Solving exponential equations right here. Same base is nice. Okay. Anytime you have same bases is very simple. All right. Guys, right here they're saying 4 to some power is equal to 4 to the what here, guys? 9. If you ever have same bases right here, we're looking to find x value that would make that true. If you ever have same bases right here, what they're saying is 4 to this power has to equal 4 to this power. Now the 4s are already the same, aren't they, kids? So it means the exponents would have to be the same. So what this means is this. If you already have the same base right here, the 4 and the 4 are the same, all I've got to do is take my x plus 3 and set it equal to what? Set it equal to 9. 4 to some power is equal to 4 to the 9th power. Well, the only way that this can be true is 4 to the 9th equal 4 to the 9th, right? So this unknown of x plus 3 has to equal what exponent up here? 9. And you can just run with it right away, because when you have like bases, you don't need to convert anything. So here you're simply going to say x plus 3 is equal to 9. What's that make the x value there? 6. X is 6. Done. And check it out, guys. If I throw 6 in up here, what's 6 plus 3 up here? 9. So this means 4 to the 9th equals 4 to the 9th. Would you guys agree that those are 2 equivalent expressions?
Yeah.
That's pretty easy. So when bases are the same. This is very easy. Just set the exponents equal to each other. Squeeze that in here. Set the exponents equal. That's all you're going to do. If the bases are the same, in that case, 4 and 4, they're the same. 4 and 4, they're the same. So I just take the x plus 3 and set equal to 9. Now I want you to be careful in part B. You have 2 is equal to 2 times 3x minus what? 2, right? There is no exponent with that first 2, right? But 2 is the same as 2 to what power?
1.
2 to the first, right? Would you guys agree that this is really the same as writing it 2 to the first equals 2 to the 3x minus 2 here? Would you guys agree with that?
Yeah.
So, my question to you then is this. Are your bases the same? What are the bases in both the left and right expression then? 2. So what are you going to do with the exponents? What are you going to do with the exponents? Set exponents what? Equal. So I'm going to set 1 equal to what value, guys? Or what expression, I should say? 3x minus. Okay, so help me two-step my way through this. Where are we? What are you going to add to both sides first?
2.
Add 2, so you've got 3x equals 3. Finally, what's your x value here?
1.
You bet. X is going to equal 1 when you're all done with this. X is going to equal 1 when we're all done with this. What do you think?
It's easy.
Good? Good? Pretty good. When bases are the same, it's easy. You guys tell me what to do on part C then. Are the bases the same?
Yeah.
What is that like base?
8.
8. All right, well help me out here, guys. What are you going to set equal to each other? 3x minus 4 equal to, whoops, oh, I'm good, I'm good. Equal to how much, Miriam? 2x plus 1, you say?
Yeah.
All right, so this is where you have variables on both sides. So I'm going to subtract 2x from both sides. Is that okay to do? Okay, so I'm going to subtract a 2x here, and I'm going to subtract a 2x here. And when I do so, here's what happens. I've got x minus 4 equals, let's see, the 2x's would cancel, leaving you with a plus 1 here. So what are you going to add to both sides to complete this?
4.
What's my solution, McKenna?
5.
X is 5. Guys, if you're solving these problems, and you're in a situation where you have exponential equations with the, what's the phrase here? Same base. Basically, just get the bases out of there, and you're setting exponents equal to each other and solving. Now, here's a better question for you, maybe. Is the base on the left always going to equal the base on the right? No. That's not going to be the case. And this is where things maybe get more difficult. So let me know that you've got everything down so far on the first page. And make sure we're moving on without questions here so far. Everybody feel pretty comfortable with that so far?
So you just picked any random number.
No.
How'd you get 6?
I set the x plus 3 part equal to 9 because the 4s were the same. If these are equal, 4 to some power has to equal 4 to the same power, which means this power and that power have to be the same. So x plus 3 has to equal what value? 9. And when you subtract 3 from 9, you get, okay? All right. So take a look at the second page here, kiddos. Told you the notes were really long today, didn't I? This is where this chart's going to come in handy for you, the one we wrote down at the beginning of the notes, all right? And maybe I should back up here, guys. It might be a situation where we have a base of 81. Now what I'm saying right here, guys, is this. If you have a base of 81, we can rewrite that as a base of what? 3. 3 to what power? Check it out with me. 1, 2, 3. 3 to the 4th power is 81. Our job today is to take something now with unlike bases and rewrite it so that we, hey, when our bases were the same, were we good?
Yeah.
We were good, right? All of a sudden up here, example 2 says solve exponential equations with unlike bases. Well, if we already know we're good at solving something where we have the same base, maybe it would be to our advantage to rewrite the equation so unlike bases were the Same basis. So I'm going to make a note up here. Let's see if we can't rewrite the problem with the same basis. That would be a good idea. Anytime you have unlike bases, for example, in this first problem, letter A, I have 6 to the x equals 1,296. Oh, no. Oh, no, you didn't. I have 9 to the x equals 3 to the x plus 2. Oh, no. Oh, no, you didn't. 4 and 8 are my bases here in part C. Are any of these bases the same? Okay, let me show you how this works. Guys, right here we have 6 to the x. Now, I don't really see a base over here because there's really no exponent. It's just a value, 1,296. But if over here on the left I have a base of 6, and I want you to think this way too. You always want to try and write your bases smaller than what they already appear. So for instance, if I start with a base of 81, do I want my base to be bigger or smaller? Try and make your base rewrite be a smaller base each time. I don't know about this 1,296, so I'm going to back up to my page right here, and I'm going to ask you a question. Does that value 1,296 show up anywhere in that chart?
Yes.
Where?
On the bottom.
Right here?
Yeah.
It's a base of what?
6.
This is 6 to the first,
Oh.
second, third.
4.
So I can rewrite 1,296 as what?
6 to the
6 to the fourth power, yep. 6 to the first, 6 to the second, 6 to the third, 6 to the fourth. Ooh. Oh.
Huh?
I've rewritten this with the what, guys?
Like
Same base. So once you've got same bases written there, what are you going to do with the bases? Kick them. Kick them out, right? Kick them out. So you're going to set x equal to what? What do you set x equal to? 4. Yeah. Once you have like bases accomplished right here, they leave. You're basically taking this exponent, setting it to this exponent, just like we did in the previous page. X equals 4. I think we're done, aren't we? Isn't x solved for there? It is, isn't it? Okay. Questions about that? All right, now this part B example, this is where things are really good for us. Guys, what are my bases first of all?
9.
9 and 3. My suggestion would be this. You want to jump into a situation where, on this chart, you can find a row where 9 and 3 both exist. So these are my powers right here, the 2, 3, 4. These are my power base. These are the bases that we're really looking at. The 3 and 9 show up in any of those rows together. 3 and 9 show up in the first row anywhere? Second row. Does 3 and 9 show up here? It does, doesn't it? Okay, 3 is 3 to what power, guys? First. And then 9 is really 3 to what power? Second. So we're going to write everything as a power of what here for part B? A power of 3. Watch what happens here. This says 9 to the x power, right? Well, we want to get these bases to match. I want this base to match this base over here. So we said 9 is really a power of 3, right? 3 to what power makes 9, kiddos?
2.
So this 9 is going to get replaced with 3 to the second. But this 9 is still to what power, guys? X power. Understand that? You understand why 9 to the x is equal to 3 squared to the x? That's 3 squared is the 9, and that x is that power that was out there. Then, this is going to equal 3 to the x plus 2 power. Like that. There was a rule that said if you have a power inside and a power outside, what do you do with these two? That was a recall rule. What are you going to do with the 2 and the x? This is really 3 to the 2x now, isn't it? equal to 3 to the x plus 2. Ah. We started with unlike bases, but now we have the now we've got the same base, right? So what are you going to set equal to each other to solve this now? What are you going to set equal to each other to solve this? Anyway,
What's the question?
I want to know what I'm going to do to solve this now.
Find the x.
Yep, find x. So how do I do that now once the bases are the same?
You divide them.
Not divide them.
You do the, well, why did you say that? Use the equation.
What's the equation?
Because I was trying to figure out.
Set the exponents equal to each other, right?
Yeah.
Yeah, once you've got like bases, set the exponents equal to each other. Very good, Carson. So what am I going to write here, kiddo?
2x equals x plus
Yep. It's basically kick the bases out. Once the bases are the same, you get rid of them and keep the exponents. Subtract x from both sides. Won't I be done?
Yeah.
What am I going to get for a solution when I subtract x, kiddos?
2.
Got x equal 2. Gnarly. There it is. There it is. Woo! Woo-hoo. Woofda. How you feeling about this? Different. Is that chart going to come in handy? That's my question.
Yeah.
It is going to come in very handy for you. You're going to need that. Ah, shoot. What are the probability I would hit that? What's the probability I would hit that?
No.
All right, kiddos, let's look at this third example right here.
9 o'clock. It's actually not. That says 8.
Guys, in part C, base is the same or base is different? They're different, right? Base of 4 and base of 8. I say look at your chart at the top of the notes. Find me a row where 4 and 8 exist. The top one.
4 and 8.
This 4 is the same as 2 to what power, kids?
1.
2 to the first, 2 to the
Second.
second power. This 8 is really 2 to the what? 2 to the third, right? So I'm going to replace the 4 with 2 to what power?
2.
And I'm going to replace the 8 with 2 to what power?
3rd.
That means our new base, our like base, will be 2 for each problem, right? Okay, so I said, hey, we have unlike bases. I ran to my chart. And I said, find me a row where 4 and 8 exist. We found them. It's a base of 2. We said we were going to rewrite this 4 as what, guys? 2 to what power? That is still 2 to the second. But what was the original exponent up here with this 4? Okay, there's 2 to the second is now that value of 4, right? But you still have an exponent out here of 2x. All agree? Then, what did we say we were going to rewrite the 8 as?
3.
2 to the third, right? This 2 to the third is that base of 8 now. But what's its exponent out here? Okay, now I want you to be very careful on this, guys. If ever I have a binomial out here, or something with an operation between a variable and number, do this for me. Make sure you put parentheses around this. Okay? Make sure you put parentheses around this, because we're going to take all of x minus 2 times that 3. So watch what happens here, guys. I have an exponent of 2 up here and an exponent of 2x. So what are you going to do with the 2 and 2x here now to form one exponent? So this is really 2 to the, what's 2 times 2x up here? 4x, right? 2 to the 4x. And this is going to equal, all right, this is where things get kind of tricky. I told you to put 1 around the x minus 2. We have to distribute this 3 to everything. 3 gets distributed to x, and 3 also gets distributed to the minus 2. So this is really going to be 2 to the 3x minus how much? 3x minus 6. Okay, there's the rewrite now with same bases. 2 to the 4x equals 2 to the 3x minus 6. Once you've got that established, you're going to kick your bases out and set the exponents equal to each other. So in this example right here, 4x is going to equal 3x minus 6. So what are you going to do to both sides at that point? Subtract out 3x, right? Subtract out 3x here. Subtract out 3x here. And by golly, x is equal to what value when you're all done there? Negative 6. X is equal to negative 6. Now kiddos, when you get to a point where your bases are exactly the same, stuff's pretty easy, isn't it? Once you get your bases to be the same, you're in pretty good shape. Oh no. Oh no. Now in example 3, they start throwing fractions at us. That's not fair, is it? Remember this rule right here? It said if I add something like 1 over 6 to the second power, this is the same as 6 to what power? 6 to the negative second here, okay? So here's the idea down here, guys. When we start having fractions as bases, once our base is a fraction, this is where things are kind of goofy. I don't like this 1/6 to the x power right here. Guys, this is really 1 over 6 to what power? This 6 in the bottom doesn't say 6 squared, doesn't say 6 to the third. It just says a 6, right? Which is really 6 to the what in the bottom then? 1, right? There's a 1 in here somewhere. 6 to the first power down here. Guys, just like right up here, top I wrote down here, I said if I had 1 over 6 squared, that was equal to 6 to the negative 2 power. All agree? Well, what's to stop me down here from saying, let's write this as 6 to what power now? Not the negative 2, but rather the... Nice. 6 to the negative 1. 1/6 is 6 to the negative 1 power. But that's still the what power out here, guys? With me so far? Now, 2/16 is a value. I'd like to write 2/16 as a base of what? Well, what base do we have right here, kids? 6. So jump into your chart. Run into the 6 right here. Does 2/16 show up here? 6 to what power? 6 to the third. 2/16 is 6 to the third. Oh, shoot, what did I do? Oh. This is really 6 to what power when I multiply the negative 1 and x? Well, 6 to the negative 1 x equals 6 to the third. Have we established like bases or same bases, if you will? Yes or no? Yeah, we have. 6. So what are you setting equal to each other to solve this puppy? What do you want to set equal to each other now to solve this? Bases are the same, so what do you set equal to each other? Bases are the same, so what am I going to set equal to each other? Exponents. Good. Very good. So we're going to say negative 1x here equals 3. What is 3 divided by negative 1, kiddos?
-3.
Thank you, John. X equals negative 3. Good stuff.
Yeah.
Who said yeah, sure. You are correct, sir. Okay, hey, quick question. What's the base in part B? What's the first base? 5. Now I have a fraction over there, 1/25. Can that 25 be written as a base of 5 somehow? Can that 25 in the denominator be written as a base of 5 somehow? How do you write 25 as a base of 5? 5 to what power? Okay, so you're ahead of me, McKenna. I'm going to do some two steps. You're ahead of me. I'm going to write this as 5 to the x plus 3 equals 1 over 5 squared. Because, guys, isn't 5 squared 25? It is, isn't it? But now we have this goofy situation where there's a 1 up top, and in the denominator I have 5 to the second. I'd like to write this as a base of 5. So if I move this to the top, my exponent of 2 turns into what kind of a 2? So this is now 5 to the x plus 3 equals what again, McKenna? So what are you going to set equal to each other now, McKenna, when you do this? And when I subtract 3 more, where do you end? So x would be negative 5 in this. X would be negative 5 in this. The whole idea today is this. Rewrite your equations so that your bases are the same. Once your bases are the same, kick them out, set your exponents equal to each other, solve for x. That's all you're doing today. Okay? Now the last example I'm going to hit here in example 4 is the following. All of a sudden they start throwing goofy values at me. I have no idea what 3.1 to the 4th power is. You guys think I'm a nerd. I am, but I'm not that nerdy. All right? I cannot tell you 3.1 to the 4th power off the top of my head. And forgive me for that, okay? Forgive me for that. I'm fired? Sweet. See you later. I'll draw unemployment. All right. So what are they suggesting you do here in example 4, guys? What's it say in the note up there? Okay, here's what I want to get at. Guys, you can also use decimals to solve this stuff. Now again, look at the example right here. I said if you ever have a situation where you're looking at something like something to the x minus 4, there's like a plus or minus sign, what do I want you to put around that when you punch that stuff in? Put parentheses in. So to solve this right here, here's how we're going to do this. Let me split the screen here. I'll jump into decimals. And I'll show you how this works, guys. Maybe I'll show you how it works. There we go. All right, watch what I do here, kids. Right here, we're going to type this in just like the following. We're going to type in 3.1 to what power, guys? So I'm going to go A to the B. I want to make sure I put parentheses up here. So x minus 4. There's your graph of that right there. Now again, which variable am I trying to solve for here? An x or a y? Just trying to solve for, the only variable that's listed in this problem is an x, right? Then, once you've got that left side into field 1, put your right side into field 2. So I'm just going to put in 9.61. Is that okay? Alright, so what you're going to have to do for that value right here, guys, let's do this. Let's get in the habit of doing this. Type in y equals each time. So in the first one, I've got y equals the left side. And then over here, I'm going to type in y equals the right side of 9.61. Okay? Do these cross anywhere? Cross right there, don't they? And it looks to me like that point is negative 6 comma, I'm sorry, positive 6 comma 9. Okay? Now we're trying to find the x value in this. So what's the x value there? Let me pull this down a little bit so I can read that better, project this for you. This point where it crosses right here, that's the point it crosses at. I want the x value. So what's the x value there? 6. 6? X is 6. Okay? So let's take a look at the second part of this. Let's take a look at the second part of this, which is, oh, there it is. All right, so what am I going to put up here for my first y value? What do you want to put in for the first y value according to this up here? 2 to the x plus 3. So I'm going to type it in as the following. I'm going to type it in as 2, raise it to a power. Anytime you have that binomial, like an x plus 3 or something has an exponent, what am I suggesting you put around those again? You get those parentheses in there, you bet. So what do I want to put up here for an exponent, kiddos?
X plus 2.
X plus 3. And then over here, we're just simply going to type in y equals x plus 3. And I want to find my point of intersection, so I'm going to drag my graph up here.
They don't intersect.
Got a question, do they cross anywhere? And if two lines don't meet, are they ever equal to each other at any point? So what are you going to say about something like this? Since those lines never meet, there's not, it's just like parallel lines. Remember when we said we had parallel lines to systems of equations? We said parallel lines means no solution.
Yeah.
So if these lines don't touch each other, can there be a solution? No. So I'm going to make a note right in here that says the following. Since lines don't meet, there is no solution. Whoops. Okay. So my suggestion is this. Anything for graphing, the left-hand side of the equation, put y equals the left-hand side in field 1. Put y equals the right-hand side in field 2, and then look for your intersecting points. Okay?
Why does it go from x minus 3 to x plus 3?
Did I type something in incorrectly?
You put it
Oh, I screwed up. I did screw up. Never mind. Never mind. Thank you, Taryn. Nice catch. My mistake. Should be x minus 3, right? Oh. Well, they still don't cross, right? They still don't cross, right? So still be no solution, right? I got lucky there, didn't I? I got lucky. I should go buy a lottery ticket today. I think I will.
No, it's because then you'll forget and then you'll never come back.
Oh, I'll be back. All right, I'm going to go ahead and stop this here. I'm going to